Hello, Precalculus students. This is Mr. Folger. Today we are on the sum and difference identities notes. So you're going to need a unit circle for this set of notes here. I put one on the right here. I will also post a PDF of this so you have it. And you can use that for your reference when you're working on this stuff. So today what we're going to talk about is how to find the exact value of the sine or cosine or tangent of an angle that is not on the unit circle. So on this unit circle, we know we can find the values of 30, 45, and 60. We know the sine is the y value and the cos is the x value. And we can also find any multiple of those in the other quadrants. Unfortunately, for this first problem, if I want to find sine of 105, there is no value for that on the unit circle. So we need to use the other ones to find it. So the first thing we can do is think about what two values do I know that I can add to 105. So let's think about that. So sine of 105 is the same as sine of what plus what? Well, it's the same as sine of 60 plus 45. So 60 plus 45 equals 105, so I can rewrite this here. And since I know the sine of 60 and the sine of 45, using this formula, I can find the exact value. So sine of a plus b is sine of a times cos of b plus cos of a times sine of b. So this will be a and this will be b, and let's write that formula out. So I'm going to have sine of 60 cos 45 plus cos of 60 sine 45. I know the exact value of each one of those things, so let's find those on the unit circle. Sine of 60 is going to be the y value at 60. So at 60, the sine of 60 is square root of 3 over 2 times the cos of 45 is the x value at 45, so square root of 2 over 2 plus cos of 60 is the x value at 60, which is 1/2. And the sine of 45 is the y value at 45, which is square root of 2 over 2. At this point, it's just simplifying. So if I multiply these, I get square root of 3 times square root of 2 is square root of 6, over 2 times 2 is 4, plus 1 times square root of 2 is square root of 2 over 4. And to add fractions, all you need is a common denominator, which I do have. So my answer here is square root of 6 plus square root of 2 all over 4. Now the answer is a little bit ugly, but that is the answer. That is the exact value of the sine of 105. Okay, so that's how we're going to do this. Now, could we have subtracted to get that? Maybe, and we will talk about that a little bit later. But right now, let's go to the next one, cos of 165. So 165. So this first part might take a little bit of guesswork. 165 is 180 minus 15, but we don't have 15 on there. Okay, 165 is 120 plus 45. Let's look and see if we have 120 and 45. We have 120 right there, and we have 45. So since I know both of those values, I can rewrite this as cosine of 120 plus 45. At this point, let me block this off. At this point, it's the same process. So use the cos of a plus b, and this will be a, and that'll be b. So cos of a plus b is right there. So cos a times cos b minus sine a times sine b. So let's write that down. So cos, oopsie, that's a highlighter. Cos 120 times cos 45 minus, right, sine A times sine B. So sine 120 sine 45. So let's find all these things. So cosine of 120 is the x value at 120, which is negative 1/2, times the cosine of 45 is the x value at 45, which is square root of 2 over 2. Minus the sine of 120 is square root of 3 over 2 times the sine of 45 is the y value here, square root of 2 over 2. At this point, it's the same process. Negative 1 times square root of 2 is negative square root of 2 over 4. 2 times 2 is 4. Minus square root of 6 over 4. And then remember, to combine fractions, they just need to have a common denominator, which these do. So negative square root of 2 minus square root of 6 all over 4. And there is your answer for question number 2. Okay, moving on to the next one. So now, the next one's in radians. An easy solution for a problem that's given to you in radians is just convert it to degrees. So do 19 times 180, which I'm doing in my calculator right now, and then divide that by 12. So this is 285 degrees. So we need to figure out, okay, what adds or subtracts to 285? Well, there's more than one way to do this, okay? So using 285, we want to find two values on this unit circle up here that either add or subtract to 285. See if you can do that on your own. I'm going to test out a couple things. Let's see, 225 plus 60. That's 285, right? So that would work. I could use a sum formula. 225 I have, and I have 60. So that would work. But let's do an example of a subtraction. So what minus what equals 285? Well, let's try 315. Oopsie. 315 minus what is that? So that would be minus 30, right? 315 minus 30 is 285. Do we know the values for 315 and 30? We sure do. 315 and 30. So let's use a subtraction. So let's write this as 315 minus 30. So we want a cos of A minus B, which is this one. Now, we could have used the plus one like I showed you over here, but just so you can see an example of subtraction here. So cos of A minus B. So it's going to be cos A times cos B plus sine A times sine B. So cos 315 cos 30 plus sine 315 sine 30. All right, and then we just find all those values and simplify it. So cos of 315 is the x value at 315, which is square root of 2 over 2. The cosine of 30 is square root of 3 over 2, plus the sine of 315 is the y value here, negative square root of 2 over 2. And the sine of 30 is the y value for 30, which is 1/2. And at this point, we just simplify. So again, square root of 6 over 4 plus negative square root of 2 over 4, which ends up being square root of 6 minus square root of 2 over 4. Okay? Again, there were multiple ways to get that answer. If you look on the answer key, there's actually another way. They just left the whole thing in radians, but they actually did it using different numbers, which is fine. I think they might have used 330 minus 45 instead of 315 minus 30. But either way, they got the same answer. You can check that on your own if you want. All right, number 4. Number 4 says sine of negative 5 pi over 12. So the first thing we want to do is convert that to degrees. 5 times 180 divided by 12. So 5 times 180 divided by 12, so we have 75. So this is negative 75. Now, negative 75, one way to do this, and probably the easiest way to go about it, is just make that a positive angle. So what do you add to make it positive? You add 360. So this is negative 75 plus 360. Is 285 again. So there's 285. So we used 3, 15, and 30 last time. Let's pick a different one. Why not? Let's do 330 minus 45. That's another way to do this. Slightly different, but they both give you 285, and we know 330, which is here, and 45, which is up here. So we know both of those, so let's do this. So sine of A minus B. All right, that's this formula up here. So sine of A minus B is sine A times cos B. So it'll be sine 330, sine 330 cos 45. And by the way, when you're doing subtraction, the B is a positive number. Sine A cos B, and then minus cos A sine B, minus cos 330 sine 45. All right, so sine of 330, the y value here is negative 1/2. You don't need parentheses here. You can if you want. Negative 1/2 cos of 45 is the x value at 45, which is square root of 2 over 2, minus cos of 330 is square root of 3 over 2, and the sine of 45 is square root of 2 over 2. And then we simplify. So negative square root of 2 over 4 minus square root of 6 over 4, which is negative square root of 2 minus square root of 6 over 4. And again, if I went a little bit quick there, it's the same as the other ones, but you can always pause it and come back to it. So the last one we're going to talk about is tan. The tan formula is a little bit more complicated, but it really is not that much different. You just got to do a little bit more algebra at the end. So the first thing I'm going to do is convert this to degrees. 13 times 180 divided by 12. 13 times 180 divided by 12. Oops. 13 times 180 divided by 12. So 195. All right, so there's always a bunch of ways to do this. We can either add or subtract to get that. You can usually find ways to do both, but let's look at 195 and think about, okay, so what two numbers can we use to add to 195? So 195, I'm going to do 195, let's see. So 150 plus 45 will work. Because I know what I'm doing is I'm checking up here. I thought of 150 plus 45, and then I'm checking. Do I have 150? Yes. Do I have 45? Yes. So I can do that. So we're going to use tan of A plus B. All right. So let's look at the formula for tan of A plus B. It's right up here. Tan A plus tan B on top. So let's do that first. Tan A plus tan B. So tan 150 plus tan 45 all over 1 minus tan A times tan B. 1 minus tan 150 tan 45. Now, for this problem, we have a little bit of extra work here. And the reason is because tan of 150, you have to remember, is y over x. Remember, tan equals y over x, which is 1/2 over negative square root of 3 over 2. So let's do that real quick. This is tan of 150. So that's going to be 1 over negative square root of 3, which if I rationalize that, is negative square root of 3 over 3. So that's going to be the tan of 150. So let's plug that into all the tan 150s here. So negative square root of 3 over 3 plus, and then we don't know tan of 45 yet, but 1 minus negative square root of 3 over 3 times, and then we just got to figure out what tan of 45 is to plug in here and here. So tan of 45, let's do y over x for 45. Square root of 2 over 2 over square root of 2 over 2. This one actually works out quite nicely because that's just 1, right? Those go away. Square root of 2 over 2 is 1. So this is plus 1, and then that times 1. All right, so now we simplify. So let's do, this one I don't need the 1. Let's do a common denominator. So everything needs to go over 3. So you need to multiply top and bottom of that one by 3, top and bottom of that one by 3, and then this 1 is just multiplying by 1, so we don't have to do anything with that. So let's see what we have. We have negative square root of 3 plus 3 over 3 all over 3 minus negative square root of 3, which is plus square root of 3 over 3. And then we can cancel these. So we have negative square root of 3 plus 3 over 3 plus square root of 3. Now, this is technically the correct answer. This is the answer that we want. But if you remember, we cannot have a square root in the denominator. So how do we get rid of that? Well, remember we multiply by the conjugate of the bottom. Remember, you multiply by the conjugate of the bottom. Now, I'm not going to make you do that. For our sake here, you can leave your answer just like this for now, and that would be okay. All right? But if you want to do that extra step, you'd multiply by the conjugate and get rid of that, but I don't want to add any confusion to this. We'll deal with that more in the next lesson. All right? So for your homework, I want you to do number 1 through 7 odd. Let me know if you have any questions. And remember, you have a graded assessment coming this Thursday, so keep an eye out for that. Thanks a lot. Bye.